In the 1960s, astronomer Dr.Frank created the so-called Drake equation, which is supposed to be able to calculate the number of extraterrestrial civilizations in the Milky Way. The parameters of the equation include the annual star formation rate of the Milky Way, the proportion of stars with orbiting planets, and the number of potentially habitable planets. How many alien civilizations could potentially live in the Milky Way? Have you ever thought about that? What else could this theory reveal about life in the universe? Some years ago, scientists at the University of Nottingham used an updated Drake equation to determine that 35 intelligent life forms probably live in the Milky Way alongside humanity. As a basic assumption, the scientists used the conditions on Earth that make it possible for intelligent life to develop on our planet. They then calculated how many similarly sized exoplanets within the Milky Way lie in the habitable zone of their star. That means they are neither too hot nor too cold for life. The basic idea, according to scientists, is that science works the same way everywhere in the universe. According to their theory, if all the criteria for intelligent life as on Earth are met, intelligent life will also develop at some point. The physicist Frank Drake presented the Drake equation, a method for calculating the number of intelligent life forms in the Milky Way, back in 1961. According to Drake, the calculation only requires the multiplication of 7 factors, all of which are unknowns. The new method can therefore be described as the Drake equation 2.0. The new Drake equation takes into account the total number of stars in the Milky Way, the proportion of stars with an age of at least 5 billion years, and the proportion of stars in the habitable zone. In contrast to the first version of the Drake equation, the number of variables required is therefore significantly smaller and can be determined from current observational data. Only the fourth variable, namely the average lifetime of a civilization from the point at which it can send signals, such as radio waves, into space, divided by the time it takes for life to form on a habitable planet, could only be estimated by the authors of the current study. They therefore developed a series of scenarios, ranging from conservative to optimistic, which indicate between 4 and 211 actively communicating civilizations in our galaxy. 36 intelligent life forms, including humanity, are the most likely. In addition to the number of extraterrestrial civilizations, the scientists also calculated the probable distance, which they put at an average of 17,000 light-years. Detection of any communication is therefore impossible with current technology. On the other hand, the minimum distance, which according to the calculations is only a few hundred light-years, gives us hope of contact in the near future. However, this is only plausible if the lifespan of an intelligent civilization is at least 1 million years. Scientists state that this seems very long when we look at our own civilization. Scientists also explain that if we were to find many extraterrestrial civilizations very close by, this means that they have managed to exist for long periods of time despite problems such as global warming or possible wars. There are more theories regarding the question if extraterrestrial life is present. As reported by the Royal Astronomical Society, scientists at Durham University have now developed a new model that focuses on the accelerated expansion of the universe and the number of stars formed. The formula is based on the assumption that the expansion of the universe is driven by dark energy, which makes up over 2/3 of the universe. According to a publication in the monthly notices of the Royal Astronomical Society, stars form the basis for habitable planets, and thus the basis for the emergence of life. In the new model, the astronomers have therefore used them to estimate the probability of the emergence of intelligent extraterrestrials in our universe and in a potential multiverse. The scientists did not attempt to calculate the absolute number of aliens, as the Drake equation did for the Milky Way, but instead determined the relative probability of life being present in a universe with certain characteristics. Surprisingly, the scientists concluded that Earth is not in a hypothetically optimal universe. The new formula shows that a significantly higher density of dark energy would have to exist in a universe than in our universe for there to be a high chance of life. According to the model, which calculates the proportion of ordinary matter that has been converted into stars over the entire history of the universe at different densities of dark energy, the proportion in a universe that forms stars most efficiently is significantly higher than in our universe, where it is around 27%. Earth is therefore not in the hypothetical universe with the highest chances of forming intelligent life forms. Understanding dark energy and its influence on our universe is one of the greatest challenges in cosmology and fundamental physics. The parameters that determine our universe, including the density of dark energy, could explain our own existence.